Hi there everybody, welcome to another MCAT ACE video, and in this particular lesson we are going to be covering periodic trends. So this is when we look at the periodic table, the various trends that we come across or the assumptions that we can make as we go across the various families and periods in the periodic table. So you can see from the outline here what we would like to cover. The very first thing, we are going to lay out a brief reminder of valence electron structure, which is the outermost set of electrons that we find in a particular column for the periodic table. We're then really, the first part of this video is going to discuss effective nuclear charge, and sometimes you may see this abbreviated as ZEFF or Z effective, charge effective. And what this really is it's a look at the proton to electron ratio, and the effective nuclear charge is going to be able to explain most of the other trends that we come across. So it's very important that you understand how effective nuclear charge works, and then subsequently you can get a grasp on atomic radius, ionization energy, electronegativity, and electron affinity, which are the major trends that we come across when we're dealing with the periodic table. So with effective nuclear charge, we'll take a look at the general trend. We're going to talk about how protons will influence the effective nuclear charge and basically what effective nuclear charge actually is, how it works. We're going to talk about what happens as we continue to pile on electrons, and specifically what happens if we open up a new shell and we place additional electrons into that shell. So in other words, what happens if I go from a 2s to a 3s? How is that going to change or manipulate the effective nuclear charge? And then the rest of these, the subsequent list here, is going to be based off of understanding effective nuclear charge. So you have atomic radius trends. This is also going to include ionic radius. So what happens if we start tossing out electrons or gaining electrons? And then we'll talk about isoelectronic sets. And isoelectronic is just a fancy word for the meaning of same electronic charge. So in other words, anything in an isoelectronic set should have the same number of electrons. Now, not necessarily the same number of protons, so that's going to be important when we come to that. Okay, then we'll talk about ionization energy and ionization energy trends. Ionization energy is the energy required to remove an electron from an atom. So we can do that. We could also do that more than once. So for instance, if I have something like magnesium that would have a 2+ charge, I have to take the first electron from magnesium, that would make it 1+, and then I would need to take a second electron from magnesium in order to make it 2+. So we're going to talk about what happens as we continuously attempt to pull more electrons away from a given compound. And then there are two major exceptions to the ionization energy trend. We'll take a look at those and briefly explain why they exist. And then we will take a look at electronegativity trends, which we have discussed in some other videos. Bond classification and polarity. So electronegativity talks about how well an element is going to take a hold of or share electrons when it's involved in a bonding relationship, and this can classify the bond as nonpolar, covalently polar, or all the way up to close to ionic, depending on the difference in electronegativity values between the bonding partners. And then finally, to wrap up, we'll look at electron affinity. And electron affinity is really the desire to gain an electron. So a lot of times students will cross electronegativity and electron affinity, which is understandable because they're very similar. But electron affinity is when an element is looking for an electron. It's actually the amount of energy that's going to be released upon picking an electron up. And so the more energy released when an element picks up an electron, the more desperately it needed or wanted that electron. Okay? And electronegativity is when you're already involved in a bond. So let's say fluorine's looking for an electron. In that case, we're talking about electron affinity. But let's say that fluorine has found a hydrogen with one electron to share. And in that case, when we're looking at the hydrogen-fluorine bond, we're talking about fluorine's electronegativity, its pull, now that it's already involved in the bond and the sharing of the electrons with hydrogen. So that's the difference between those two. Electronegativity, you already have bonds set up. Electron affinity, you have the element looking for an electron. It's not involved in a bond quite yet. All right, so hopefully that helps to clarify the difference between those two. So let's go ahead and bring up our periodic table.